So before we look at our first example, let's first talk about the notation that's used for walks. So let's say I have this graph here, and then that. So this will be vertex 1, vertex 2, and vertex 3 will be there. This will be edge 1, edge 2, edge 3, and edge 4. So if I talk about edge 1 to edge 2, edge 3, and edge 2, edge 4, and edge 3, this refers unambiguously to the walk. So in order to go from edge 1 to edge 2, you would have to go from vertex 1, edge 1, to vertex 2, edge 2, vertex 3, edge 4, to vertex 3, to edge 3, to vertex 2. So this refers to the walk from vertex 1 to vertex 2. And this is kind of a long way to write this walk, so we will use this shorthand notation when it's unambiguous. But if in that same example, if I just write E1, edge 1, this could refer to two different walks. It could refer to vertex 1, edge 1, vertex 2. It could start at vertex 1 and end at vertex 2, or it could start at vertex 2 and end at vertex 1. So as long as it's unambiguous, we will use this as shorthand notation, but if it is ambiguous like it is here, we would use this expanded out notation. All right, so we're going to look at a graph. So let's look at our example here. Say, in the graph, determine which of the following walks are trails, paths, circuits, or simple circuits. So it might be helpful if I'm going to draw this graph right now, but it might be helpful if you have the table from the last video with these different terms in them. It might be helpful if you refer to that. So give me just a minute. We're going to draw this graph E1, E2. From vertex 2, there's these two here. This is vertex 3, vertex 4, vertex 5, vertex 6. This is edge 3, and then edge 4 will be here. Edge 5, edge 6 will go here, edge 6, edge 7, and this will be edge 8, edge 9, and edge 10. Okay, so let's start with vertex 1, edge 1, vertex 2, edge 3, vertex 3, edge 4, vertex 3, edge 5, vertex 4. So the first thing that I see is that there is a repeated vertex. There's a repeated vertex. But if you look at the edges, the E's, there's no repeated edges. So if you look back at your table, which ones could I have a repeated vertex and no repeated edge? This is a trail from V1 to V4, but it's not a path. So I'll say it is a trail, but it's not a path. So if you look back at the table, it's not a path because it has a repeated vertex. Let's look at another one. Let's look at B. Edge 1, edge 3, edge 5, edge 5, and edge 6. So this is an example where they use shorthand notation. So if you look back at the picture, you can figure out which path they're, or which walk they're talking about here. This is V1, E1, to V2, to E3, to V3, to E5, to V4, and then edge 5 again, back to V3, E6, to V5. So there's only one walk that this describes, and it's this one. So this is a walk from vertex 1 to vertex 5. And if you look, there is a repeated edge. So this is not a trail because it has a repeated edge. Okay, the next one will be vertex 2, vertex 3, vertex 4, vertex 5, vertex 3, vertex 6, and vertex 2. So again, this is shorthand, so you might want to expand out this and see which walk is it describing. So if I start at vertex 2, I would take edge 3 to get to vertex 3, edge 5 to get to vertex 4, edge 10 to get to vertex 5, edge 6 to get to vertex 3, edge 7 to get to vertex 6, and edge 8 to get to vertex 2. So this is a walk that starts and ends at vertex 2. It contains at least one edge. And it does not have a repeated edge. If you look at all the edges, none of them are repeated. So this is a circuit. It is not a simple circuit because if you look, you have a vertex that is repeated. You have a vertex 3 that's repeated in the middle. So vertex 3 is repeated in the middle. So we're going to look at one last one. Let's look at D. Vertex 2 to vertex 3 to vertex 4 to vertex 5 to vertex 6 to vertex 2. So again, maybe want to expand this out. Which walk is it? Include all the edges. So this goes from vertex 2. Edge 3 takes you to vertex 3. Edge 5 takes you to vertex 4. Edge 10 takes you to vertex 5. Edge 9 takes you to vertex 6, and edge 8 takes you to vertex 2. And so this is a walk that starts and ends at vertex 2. It contains at least one edge. And if you look at all the edges, there's no repeated. Does not have a repeated edge. And it also, other than the beginning and end, does not have a repeated vertex other than the initial, the beginning and end. So this is a simple circuit.